geobyte.
Try to read it clearly. It is asking like this. Two bodies are projected from ground with the same speeds, that is 40 meter per second. U1 equal to U2 equal to 40 meter per second. Two bodies are projecting from the same point, right? From the same point, two bodies are projecting from the ground with the same initial velocity U1 equal to U2, that is equal to 40 meter per second. Two different angles, that means theta 1 and theta 2 are different with respect to horizontal. Okay, with respect to horizontal. Two bodies were found to have the same range. R1 is equal to R2. The two bodies are maintaining same range. Dear friends, remember, for the same initial velocity and same range, the sum of the angles must be equal to 90 degrees. This is the very, very important condition. Here, theta 1 given, one body angle is given. If one of the body was projected at an angle 60 degrees, theta 1 60 degrees plus theta 2 equal to 90 degrees. From this, I can write that theta 2 equal to 90 minus 60, that is equal to 30 degrees. Okay, with the horizontal. The sum of the maximum heights attained by the two projectiles. What is the H1 max plus H2 max? H2 max. Understood? Yes. Let us take another slide. Here H1 max plus H2 max is equal to, H max formula equal to U square sine square theta by 2g. Okay. Na? Then here it is U1 square sine square theta 1 by 2g plus U2 square sine square theta 2 by 2g. Here u1 equal to u2. u1 square divided by 2g into u1 equal to u2. u1 equal to u2, that is equal to u. That is given. How much it is given? It is given 40 meter per second. It is 40 meter per second. Let us write just u square. U square into sine square theta 1 plus sine square theta 2. Now substitute the values. 40 square by 2 into 10 sine square theta 1 is 60 degrees plus sine square theta 2 30 degrees. Simplify this. 40 square means 40 into 40 dividing by 20 sine 60 root 3 by 2. Then sine square 60 equal to 3 by 4 plus sine 30 equal to 1 by 2. Then sine square 30 1 by 4. Simplify this value. Here it is 2 times 80. 80 into, right? It is 80 into, it is 3 by 4 plus 1 by 4 equal to 1 only. Is equal to 1 only. 4 by 4. That is equal to 80 meters. Right? Answer is 80 meters. I hope all of you clearly understood. Understood? Or? Yes. Dear students, look at the another problem. Try to read it clearly. It is asking like this. The initial speed of a projectile fired from the ground is u. At the highest point during its motion, the speed of the projectile is root 3 by 2 u. The time of flight of the projectile is. It is like this. A projectile is fired from the ground at an angle, let it be theta, with initial velocity u. This is the highest point. This is the highest point. Let me write it clearly. That is the highest point. At that highest point, the velocity is given as root 3 by 2 into u. At the highest point, it is having no vertical component of velocity. It is having only horizontal component of velocity. That horizontal component of velocity at the highest point, ux, equal to u cos theta. That means indirectly, the given value is equal to u cos theta. Okay. Then this u is cancelling. Cos theta equal to root 3 by 2. Therefore, theta equal to 30 degrees. That's the theta. You're asked to decide the time of flight. As you know, time of flight, time of flight, capital T equal to 2u sin theta by g. 2 into u into sin theta. Theta is decided 30 degrees. Sin theta, sin 30 degrees divided by g. 2 into u into sin 30 equal to 1 by 2 dividing by g. This 2 is cancelling. This 2 is cancelling. Finally, it is equal to u by g. So time of flight is u by g. Look at the options. Option B. Option B is absolutely correct. Understood clearly? Yes. Here at the highest point, no vertical component of velocity. Okay. Similarly, look at the next problem. Try to read it clearly. It is asking like this. The speed of a swimmer is 4 kilometers per hour in still water. In still water means in the water where the water is not flowing. It is like this. It is like this. Look at the water. Assume this is the still water. The speed, velocity of the man or swimmer is 4 kilometer per hour. If the swimmer makes his strokes normal to the flow of river of width 1 kilometer. Width of the river is given 1 kilometer. 1 kilometer. He reaches a point 750 meters down the stream on the opposite bank. This may be the starting point of the swimmer. This is the starting point of the swimmer. The swimmer tries to swim in this direction, but it is given that the water is flowing. Assume the water is flowing with a velocity Vw. By the time the swimmer or man is right maintaining the Vm velocity, by that time the swimmer is reaching to other end at a distance 750 meters. That means 0.75 kilometers. Kilometers. Instead of reaching the B, he is reaching the C. Okay. Now the speed of the river water is, what is the river water speed? What is the water speed in the river? Okay. So when the water is at rest condition, the speed of the man given. Then speed of the man equal to distance traveled or distance traveled dividing by the time taken. Time taken. Here, time taken equal to distance traveled equal to width of the river only, that is 1 kilometer dividing by speed of the man 4 this is equal to 1 by 4 hours. 1 by 4 hours. Okay, this is the kmph. Okay, now, so that is the time taken. Then river water velocity is equal to river water velocity equal to the displacement of man due to river water flow, due to water flow, due to water flow dividing by the time taken. Time taken. It is given that the displacement of the man due to river water flow is 0.75 kilometers. 0.75 divided by time taken 1 by 4. It is equal to 0.75 into 4 is equal to 3 kilometer per hour. That is the answer. Answer is 3 kilometer per hour. Understood clearly? This kind of problem is very, very important. Right? Very, very important. Very, very important problem. Okay. Similarly, let us take the another problem. Try to read it clearly. It is asking like this. A stone tied to 180 centimeters long string at the end is making 28 revolutions in horizontal circle in every minute. It is like this. A stone is tied. Let this is the stone. This is the stone. The stone is tied to the string. The stone is tied to the string. This is the center of the string or center of the circular motion. The time taken. What is the time taken for each revolution? 1 minute. Time taken per revolution is equal to 1 minute. Is equal to 1 into 60 seconds. That is nothing but 60 seconds. Okay. The magnitude of the acceleration of stone is, that means centripetal acceleration is given 1936 dividing by x meter second power minus 2. The value of x is, what is the value of x? That's the problem. As you know, centripetal centripetal acceleration centripetal acceleration is equal to omega square r. This, what is the r value given? Is it r value given? Radius of the circular path is nothing but the length of the string, that is equal to 1.8 meters. It is given in centimeters, converted to meters. I got r value. Omega, I need to decide the omega value. Omega value how much? Omega equal to angular displacement dividing by the time taken. Angular displacement for each revolution, it is 360 degrees, that is equal to 2 pi radians multiplied by how many revolutions it is made? 28 dividing by the time taken is 60. Is 60. It is equal to 2 into pi value given. Look at the pi value, 22 by 7. 22 by 7 into 28 divided by 60. Divided by 60. So let me take another slide. Omega equal to, let me write it clearly. 2 into 22, 44 into 28. 44 into 28 dividing by 7 into 60. 7 into 60. Then centripetal acceleration AC equal to omega square r, no? Omega square 44 square into 28 square divided by 7 square into 60 square into 1.8 omega square r. You simplify this value for getting 1936. 1936 dividing by 125. But what it is given? Centripetal acceleration given 1936 dividing by x. Is it correct? 1936 dividing by x. You are asked to decide the x value. They compare these two, this value and this value, for writing x equal to 125. That's all. X equal to 125. So answer is 125. I hope all of you understood. Understood, Arun? Yes.
Geobyte.